Welcome to the HPE Developer Hack Shack, and this workshop is an introduction to virtual machine infrastructure as code using Terraform and HPE GreenLake for private cloud enterprise. So my name is Didier, and I'm going to walk you through this workshop on demand. And we are going to use, and this is actually what you see on your screen right now, Jupyter notebooks throughout the lab. So if you're not familiar with Jupyter Notebook, let me just explain how this works. A notebook is basically, and we have actually 4 notebooks in this workshop, but a notebook is a series of cells, we call them. Cells can be either a code cell, or it can be a text or graphic information cell, let's call it this way. You can run a cell, and you can run a cell by using the little play button at the top when you are on a particular cell, and this is highlighted by the blue bar on the left that I'm showing here. So if I run a text like this one, a text or graphical, it just renders it, and this is markdown, but it renders it so it looks good. You can also use Control-Enter and Shift-Enter. The difference here is that with Shift-Enter, you just run and go to the next cell on the code cell. And if you use Control-Enter, you stick to the same cell. That could be useful when you want to monitor some state of something where you can run the command multiple times. An important thing to note, though, is that when you run a cell, and I'll show you this at the first code cell that we will hit. But when you run a cell, you will see that there is a mark that shows you that it's running, and it's a little asterisk on the left side of the cell. You can only run one cell at a time. So while this is still going on, and you will see that with Terraform, we've got a few lengthy command that you need to wait for the end before you move to the next cell. You can't really run another cell until this one is gone to a number. And the number is kind of and then the order of the execution. So remember just that if you have a star, you can't run another cell. You need to wait for the end of it. All right, that's about it for understanding Jupyter Notebook. It's pretty, you'll see it's pretty user-friendly. So the workflow of the workshop is we have 3 labs. Lab 1 will be creating resources with Terraform. Namely, we'll be creating a virtual machine through a Terraform syntax. In Lab 2, we'll be playing with that virtual machine and changing some of its state. And so by altering the configuration file in Terraform. And finally, Lab 3 is pretty easy. We'll be decommissioning the resource that we used in GreenLake. So it's a pretty easy one. Then we'll jump to a conclusion. Okay, let's jump into Lab 1. The Lab 1 really introduced the notion of infrastructure as code. The idea here is that over time, it's been really important for people managing infrastructure to be able to do it with no errors systematically, so that they have a recipe and everything is always deployed or worked the same way. And basically this has introduced the notion of infrastructure as code, which is a way to describe with some sort of a language the desired state of your infrastructure. There are several ways you can do that, and there are several tools to do that. Terraform is one of them. Other ones would be Ansible, Chef, or Puppet are also considered infrastructure as code solution or frameworks. The great benefit of having implemented infrastructure as code is that you can then manage your infrastructure as a piece of code, because that's what it is. This recipe that you describe is a source code. It's written in text. It can be managed the same way you manage your application code. So you can store it in GitHub, for example, together with the application that your infrastructure will be hosting. That's an example. And this is also sometimes called as shifting left, which is putting the infrastructure earlier in the deployment pipeline of an application, so that you get the infrastructure deployed and managed earlier in the process as you're building your application over and over again during the building of it. So we will be using Terraform. So this is an open source. I forgot to say, it's important to know it's an open source solution that was originally built by HashiCorp. And as an infrastructure, we will be using HPE GreenLake. So HPE GreenLake is HPE offering for an H2 cloud. It is an H2 cloud platform. It's a self-service. It has all the capability of a cloud, self-service, infinite scalability, pay as you go, and manage for you. And part of the GreenLake offering is a number of services. And we have lots of services in HPE GreenLake, and you can check out those links. We're not going to do that right now, but you have SAP services, HPC services, VDI services. One of the services we provide is called Private Cloud Enterprise, and this is the one we're going to be using. So Private Cloud Enterprise is a combination of virtual machine capability plus container as a service, if you want, plus bare metal as a service. So you can have the three options depending on the workloads. And in order to view some of the things we'll be doing with Terraform from the workshop, we have a console onto the HPE GreenLake cloud platform. So let me just quickly show you that. So if you click on that link, actually I had it open already, and if you follow the instructions here, we have a username that we use for this workshop, John Doe, and a password here. So I'm going to cut and paste that. You can do the same. And select John Doe. Well, actually, the password is already there for me, but you can sign in with that password. And we won't do much there. We'll just keep an eye on it so that we can see the impact of what we do in our Terraform configuration file on the backend GreenLake infrastructure that we have available. Okay, so we have our GreenLake console here. You're gonna have to bear with me with the naming of this. It's actually a console that was used. The service name is the new name of the service. Sorry, is Private Cloud Enterprise, but the service that we have in this environment is the original name. So, but it's more or less the same. So we'll keep the window available on the VM instances because we'll be working with the VMs here. And as you can see, we have no instance right now. So let's go back to our workshop. You don't have to go to the GreenLake dashboard every time because we provide also screen captures of what should be happening. So, but if you want, you can go and check the live systems. Okay, Terraform, as I said, was developed by HashiCorp. It's written in Go and it's open source today. And basically, it's a solution which takes as input a desired state of infrastructure. And this is described with a HashiCorp configuration language, an HCL file. More recently, they also allow a JSON input file. But in this case, we're going to use HCL. And then another important thing is that Terraform works with the notion of providers. So a provider, think about it as a plugin. You can have plugins for GreenLake, of course, this is what we're going to use, but you can have plugins for other clouds, for VMware, for all sorts of storage and networks and pieces of the infrastructure. So infrastructure providers are the ones building the providers so that people can use Terraform to manage their piece of infrastructure. As I said earlier, there are other solutions than Terraform. For example, Ansible is a very popular one nowadays. Anyway, we decided to use Terraform here. And the first thing we're going to do, and this is also to show you a first code cell. So you see here, the current cell is the blue bar here. So if I run it, I go to the next one, which is still text. But if I run it and I go to this one in blue here now, this is a code cell. And actually, let me show you. So you see that it has this little brackets here showing the state. And right now it shows nothing because it's not running. On the upper right corner here, you see bash because the cells we're going to use are going to be only bash cells. But in Jupyter Notebook, initially Jupyter was created with Python. So the native, if you want, language in Jupyter is Python. But today it's becoming a very popular solution, especially in the data science and academic world. And you can find more than 60 kernels, we call them kernels, that can be that can back up your basically your cells. So a cell in Bash needs a Bash kernel to run, which we installed in our environment here. But you could use other things like Rust or Python or Java or Go or whatever. So don't change that, of course, because if you change it, it won't work anymore. So let's run this first cell. As I told you, you can do Shift Enter, or you can just run the button over there. The cool thing with Jupyter Notebook is the output of a command is always displayed immediately after the cell. So this is the output. And this is also nice because if you want to save your work, and you can save the notebook, and my suggestion is just to save it at the end of the workshop, so you have all the output together, and you can take a look at the output even without having installed a Jupyter server yourself. Okay, we know we have a Terraform running on the platform. It's version 1.33, and the next step is, in order to get Terraform to do anything, you need to create this configuration file. It's called a TF file, Terraform file. And we have one, but if you open it right now, you see that it's an empty file. And the goal of this workshop is to build little by little, cutting and pasting code snippets, this configuration file, so that we can move across the different labs. So let's go back here and let's try to first specify, the first thing we need to specify in this Terraform configuration file is what is the provider which we are going to be using. If you are looking for what's available, you can take a look at the Terraform registry. And this is a kind of a place where you can, where Terraform and HashiCorp maintain the list of providers. So if we type in, for example, HPE, you'll see that we have this HPE GreenLake Terraform provider, which we are going to use today. But you can look for other things, and anything that is part of the registry, you can install directly from a configuration file. So that's quite nice. Also interesting to know is that we provide you the link to the GitHub repo where this provider is available from HPE, so that you can report issues, or you can even contribute, because this is an open source piece of code. But let's go back here. And as I said, we need to build this configuration file. We need to say that we want to use that Terraform provider. And the syntax for that is, as you can see, some curly brackets here, required provider, and then the name of the provider, the version. You can see here in the lab, we're using an older one, but it's just because things are moving as compared to when this lab was built. So let's Control C to copy this and then start building our Terraform provider. So this is the configuration file. And remember, every time we are going to add something to the file, don't forget to save the file. Otherwise, you'll be testing the file against the previous version. So save the file, go back here, and then we can do init. That's the first thing you want to do to initialize your environment. So let's run that command. And because we selected some providers, of course, you could have more than one provider if you were talking to more than one piece of infrastructure, but this is not the case for us. The init command will configure Terraform with and install and download and install the required providers, in our case, the GreenLake provider. All right, so this looks good. Now we need to configure it. So the Terraform provider, if you look at the documentation page, which is right there, will tell you exactly what type of variables you need to set. And there's a combination of variables that you could either put in the configuration file or as environment variables. My recommendation is to follow what is explained in the documentation. Some location and space name being part of the configuration file, the Terraform, and the rest being used as export statements. So you can run this or source these files just before you run your command. So we're doing exactly this here. We are going to set up a section of the configuration file with that. So we just add to the list here. There we go. And the rest, and we tell you how to find the information in your dashboard. If you already have an account on GreenLake, you can see that the location is right here. And some of the other parameters, you would need an administrator to give you access. For example, API access keys and things like that requires a tenant admin. So we cannot really show you that, but we have a screen capture of that information. The tenant is found under your username. So if we go back here and you pull this down, you will see the space, sorry, the space, not the tenant. Okay, so we have the tenant, we have the space, we have the location. We can populate those two. And the rest, as I said, is in a configuration file. The configuration file, we already built it for you, and we can open it just to take a look, because we provision this tenant ID, secret keys, and so on the fly when you register for this workshop. So they are built on the fly, and this is are the values that we were assigned. We don't really need to change and touch anything there. All we need to do is every time we want to run the workshop, we need to source the file so all the variables are set. So let's do run here. Now we have all the variables set. And I'm explaining here how you would do with an administrative account to get those values. So you would have to go into the GreenLake in the identity and access management. And then this is where you find your API clients. This is where you will get your client ID and the issuer that we need to set up in all these parameters here. Okay. And finally, if you want to see the API access piece, then you can find your tenant ID, sorry, which we were missing from the file, tenant ID right there. Okay, so then we need to continue. We have all the basic grounds ready, but if we look in the documentation for our infrastructure, the way Terraform works is that you need to provide it with information about what you exactly want from the infrastructure. So if you look at the documentation for a VM instance, which is really what we are trying to achieve here, it will tell you the minimal amount of parameters that you would need to specify in order to build a VM instance. And even better, if you go to yeah, you can, as you can see here, this is on back on the GitHub page for the Terraform provider. You see that we have all the data sources and all the resources. So we'll use resources when we want to create a resource, and we'll use the data sources to find out about possible value for the parameters of that resource that we are trying to connect. And in Terraform, we are trying to create. And in Terraform land, this is called data sources. So you have data sources for the data store, the cluster, the groups, the network interfaces. Everything is something that you can query to find out values, possible values, and assign values to your instances that you're trying to create, of a resource that you're trying to create. Okay, so let's, so when we look at the documentation, we need the following details: a cloud ID, a group ID, a layout ID, a plan ID, an instance type code, a network ID, resource pool ID, template ID, and folder code. And the way you get this is by using, as I said, a data statement. Oops, sorry, a data statement. If this happens to you when you click on something like that, you just play run again and it will render it again. So we need to find, for example, let me just explain. We need to find a cloud ID, and the name of our cloud is this string here. So this will retrieve the name of the cloud and put the ID into a variable called cloud. And this, then we can use that variable later in our Terraform recipe, if you want, when we are at a stage where we want to create a resource. So let's, same thing here. We want to Control-C and start populating the enumeration of resources that we are trying to get so that we can create a VM instance. So I'm grabbing everything here. We'll do it all in once, but you could do step by step if you prefer. So all that we have here is instructions for Terraform to retrieve a cloud ID, a couple of networks, blue and green networks, of a cloud folder, a resource pool that was assigned to me, a group, and what kind of a plan I would like to create a VM small, for example, what OS I would like to install. In that case, I grabbed CentOS and a template. All of this will populate variables that we will then use in the next statement when creating the VM instance. All right. Oops, I forgot. What do we want to do here? Save the file, of course. Saving the file, going back here. One thing you can do with Terraform is to make sure that you didn't forget a closing curly bracket or something. You can validate. So you can say Terraform validates. It would go through the file, tell you that it's valid. So at least you know that syntactically it's correct. And then the next step is we want to create a resource, and it's a VM instance, and we will give it a name, for example, your student name, which is in my case, student 1738. So I'm going to grab that piece, which is really the only action here, because the rest is just fetching in information. And Control-C, Control-V that piece into my config file. All right. So now we have a Terraform configuration file that enumerates a number of things in order to create a new resource of type instance, VM instance, sorry, and create that instance with a number of parameters, for example, volume of root volume of 15 gig, a certain plan ID, a certain layout ID, group ID, cloud ID, and so on, so that we all fetch in the steps above. Save the file and go back to the flow here. Okay, we are ready to deploy. We can do a validate again, and we can do a plan. In Terraform, you can always plan, which really says, do as if you were to provision this, the thing I've described in my configuration file, but don't do anything. Just tell me about what's going to be done to create things initially, or even to update or change a configuration. So if you say plan, you always will get the plan, and the plan is, I'm going to add this, I'm going to remove this, I'm going to change that. So you will see that there is a kind of a syntax to show plus and minus. So let's run that. You see that there's a star here. It's going to take a little while, so don't try to run anything while, again, there is a star going on here, because it just runs. And it takes a little while, because I enabled some logging so you can see something. By default, the logging level is lower, so you don't see all these info messages. But I thought that was more interesting, and also you could see that there is still something going on. So you see, it's still reading configuration file, still getting information from the backend infrastructure using the data statements that we had at the beginning of our file. So it gets the cloud, the group, the plan, the network, the resource pool, the cloud folder. Okay. And then it's telling us, okay, an instance for client 1738, it will perform the following action, will be created. This is the parameters. Some are not set because it will only be set at create time. So we see, for example, the ID of that VM is not yet there because it's not been created yet. This is all planning to do. So we can review all the details. If something is not correct or we don't like what we see, we can always revisit the configuration file and plan again. And the summary of the plan is it's going to add one instance of a VM, but you could have more than one thing, and zero change, zero destroy. Okay. Seems like we are ready to apply. The next command we want to do is Terraform apply. Here I use auto approve. Probably don't want to use that in a real environment, because this means that even if there is a problem, or it doesn't ask you to go ahead, because what it's doing right now is it's going to do a plan again and apply it only if you say yes, because I don't want to have inputs in my cell, because this kind of is a little bit of a problem. When you have an input, you kind of lock the cell. I use the auto approve command, and I already know what was the plan, and I agree with the plan. So there's no risk here. So it's doing again the same thing, which is reading information from all the data statement in my Terraform. So we're going to see again that it's looking up plan ID and operating system ID, all the pieces that I need to feed the resource statements at the end of the file. So we see, okay, getting the template. The network was already read. Let's see. The plan, the network, the group, the layout, that's good. Terraform will perform the sorting action. We know that, and then it's doing it. So this takes another couple of minutes. We still see that we have this star here. So the cell is still active and working. And what we can do is we can also, well, let's creating new instance. So it started creating an instance on the backend infrastructure. In that case, GreenLake is still creating. So we can go back to here, wait a little bit, but the instance should appear right there. Few more seconds and we're gonna get through that. If you remember the source file here, this is where you can set the level of debug. I think we talked about that in the last lab. Come on. Okay, the VM is already in the list here. So if I click on that VM, I can see that it's got my name. It's a G1 small. It's got CentOS. What else did we set? We can look at the history here, follow the, everything is complete. We can check on storage right there. you remember, there was a root vol of 15 gigs, so that's all set. So it looks like everything is good on the back end. And if we go back to our lab, it says, okay, apply complete. One resource was added, 0 change, 0 destroyed. So in 2 minutes, more or less, and 5 seconds. So we've seen that live, so I'll skip. And that really concludes the first part of the workshop, which was to create a basic Terraform recipe or desired state file to create a VM instance. Let's move to the next workshop. So that's the second Jupyter notebook. And from here, we start with that VM, of course, already created. Because we are in a new notebook, we need to run the source, we need to reload the environment variables. So don't forget to do that. And then we can continue on. Okay, so now we have that VM. What I'd like to show you is this, how you would do desired state management once with Terraform still, of course. And then, and what we will be doing is we'll be modifying the parameters of the configuration file to change the behavior of the VM. For example, if you look at our instances here and our instance, it doesn't have any label or it doesn't have any tag. And this is something that a lot of companies are using to sort this out, sort their VMs when they have thousands of them. So for example, here we want to use a couple of labels, one for Hackshack and HP Dev. And we want to also use tags. You can do this in 2 steps, but let's do it in 1. We want to use tags, and the tags we want to use is a tag team for HP developer and a tag for support and gold for my type of support. And so let's grab that and modify my config file. So you want to be careful here, as I explained here. Now we are going to add metadata information for that particular VM. So you need to make sure you modify the content of the VM, which is between this bracket here and this bracket here. Okay, you can put it anywhere, but it has to be within these 2 brackets, otherwise it's invalid. So let's say I want to use labels, and okay, these are my labels. You can change that, of course, in the lab. And I want to also, at the same time, so I don't have to do that twice, use tags. And in most cases, people use tags for a certain number of things and labels for other things. So you can use both. And this one closes the tag, and this one closes the VM. All right, looks good here. To be sure, we save the file, of course, don't forget, and we go back and do a validate just to be sure, and then we apply. We don't plan this time, we just apply because it does a plan anyway, and we auto approve like we did before, and we see what happened. And let's go. So it's going to read that configuration file again and check against what's available there and propose a new plan. And in the new plan, it will say, oh, I need to add 2 tags and a couple of labels. And if you approve, which is automatically done in this particular case, it will go on and apply the plan. So we'll give it a minute, and I will show you where we expect to see things. So I think labels show up under the VM, and I think tags have a dedicated section here. So we'll just wait until this is modified. Let me go and check where we are right now. Shouldn't take too long to make those changes. Okay. There's a warning, but we can ignore it for now. And we see the plan before it went on and applied the changes, but the plan is to update in place the two labels and the two tags, which is what it's doing now. Still modifying, but that should be quick. So let's go take a look. I don't remember if I need to update or refresh. I don't think I need to refresh. So let's just wait a few more seconds. Yeah, this is where we're going to see the labels next to the plan. And the tags is a new section. So let's see, give it a few more seconds, and we'll take a look. Okay, the labels are there. You can see Akshak and HPE Dev, and the tags as well. There's a new section here with support is gold and team is HPE Dev. Looks like everything went well. So let's go back and wait until this finishes. There we go. So one resource was changed. Well, that was our VM. So let's move on and continue. Another use case that we see a lot when managing a virtual machine is, I need more disk space. So we want to add one extra disk to that particular VM. We can do that with Terraform. Remember, we've seen that already at the beginning. We have one disk called root_vol, and we want to add another one. So let's do this with code. We Control-C that piece. We go back to our config file. Remember, we stick to the brackets for the VM. Actually, I will put it next to the other volume, so things are nice and tight. So root vol was 15. I want to add a data vol of 25. I don't care about which data store ID. I just take automatic settings, but you have some more. Of course, you have more parameters there. You need to look at the details of the documentation, but this is the minimal amount of parameters we need. I save this file, don't forget, save the file, and I go back to lab 2 and do the same, validate and apply. A little bit more waiting for you, and we should see the changes in the storage configuration. So we can take a look at what's there before. If you remember, we had one disk, root vol called SDA for the host, 15 gig. And we expect to see another disk of 25 gig, if I remember right. A few warnings, but we can ignore. Okay, yeah, because we haven't used network green, we use only the blue one. After this last reading here, we shall see the plan, and the plan will request, I guess, one change because we had one disk and we want two disks. So that's one change on the existing infrastructure. Shouldn't take much longer. There we go. So these are all the providers. So here we go for the plan. So the plan is to update in place, and the VM instance we are trying to change. Oops, did I? Oh, no, there we go. and the volume that we're trying to add. So we see this plus. It's very similar to GitHub and the syntax that they use to show you the lines that have been added and the lines that have been removed. So this tells you that this section was added, and we are basically adding a volume. All right, so now it's doing the changes, and we need to wait just a little bit more, but I don't think a lot more. So let's go and check the live platform and see if it gets updated with the, what was the name of the volume? Data vol, I think I called it. Data vol, yes. Okay, taking more or less a minute or so. There we go. 2 disk, data vol and root vol, 25 gig, and this is SDB. So as a user of that VM, you would have to mount that volume and start using it. All right, so let's let this finish nicely here before we can move to the next use case. Actually, let me explain the next use case. So we see that one thing was changed, but the next use case is also a typical one, which is I'd like to take a snap of my VM because I'm about to install some piece of software that I'd like to uninstall at some point or restore to previous to snap. So I'd like to take a snapshot of the VM, and I can do that with Terraform as well by using that section here, which is I'm going to create a snapshot, call it snap1, put some description, that's it. So put this in your config file, still in the section of that particular VM. You can only snapshot the VM. And change the values if you want. This is just text. Save the file, most important piece, and go back to the workshop here to do one more. And I think after that we'll stop the VM with the last one. So run. Again, we're reading all the configuration file, and then we'll build a plan, or Terraform will build a plan for us about what needs to be changed for to reach the desired state that we describe in our Terraform configuration file. And what we expect to see here in the backup section, this is where the snapshots are stored. So you can go back and say, restore from snapshot. We don't have any right now. The VM was just created. So let's see what happens when we run this. So we are, again, reading the content of our configuration file. In order for the Terraform provider to, or the Terraform to provide a plan, which we should see in just a second. Right there. Okay, so the plan is to create +++++ a snapshot. And it's now doing the action according to the plan. And we should go back here and wait to see if we see a new snapshot popping up in our snapshot list. Come on. Still modifying. So let's be patient. There we go. Snap one is now available. Oh, it's actually still creating, but I'm just too impatient here. So yeah, we have a snapshot that was just created, or it's still being creating. And if we go back here, we see that it was one change was applied and we're good. So let's go back and see if it's now moved to complete. Oh, funny. Oh yeah, okay. So the snap is now complete and we can move on with whatever we wanted to do with that VM. We know we have a snap ready to deploy. Okay, so the last use case for lab 2 is we want to stop the VM. And for that, we're going to use a power on statement. And actually we're going to use a power off statement. And if you look carefully in the configuration file, you see that the power on statement was already there when we created the VM initially. So all we have to do here is change on to off, save the file, and run again. Validate and apply to turn off that VM. I didn't show you that, but actually the VM is shown here, the status is shown here. So what we will see in a minute or so is that the status turns to stopped, or kind of a square, a brown gray square or something. Yeah, like this. Okay, let me see. Yeah, while we wait for that, I already explained that you can change the level of debug you want for your Terraform commands, and you do that with tf_log, and you change it to debug information, that kind of thing. If you look, what we have right now is info, so you could change that, and I think it's what I'm asking in the lab, so we'll do it when this is finished, but just to show more information. Let's see where we have with that. Read is complete. Well, sort of. It's going to pick up the change that we require and going to propose a plan for it. And we see that the plan is to change power from on to off. We see the little arrow here. And now it's gone and applied the changes, and hopefully we should see the VM power off at some point. Let's just wait for this and we'll try the debug option. Okay. Keeping an eye on the VM, see if it shuts down and power off. Come on. Thank you. Okay, so now we are stopped. The script will tell us that everything went according to the plan. And we can move on. Okay. Okay, so we just want to show kind of an example of changing the debug value. You could change it in the source file, and or you can just export it this way. So let's run that. And if you remember, the Terraform validate is pretty short here. It goes like info, this is the version, blah, blah, blah. So maybe 6 or 7 lines, and then it goes configuration valid. So let's change the level to debug and run the same command again, just to give you an idea. So in debug mode, you get a lot more details about what the provider is actually doing. So that's a lot for just validate. But remember, if you get into trouble, that can be useful. All right, so that terminates lab 2. Let's move to lab 3. And you see it's pretty quick. What we want to do is, first of all, we need to reload our environment variables because we changed notebook, and this is a complete new environment. And all we want to do is, in Terraform jargon, is you want to do a Terraform destroy of the configuration you still have in your configuration file. So everything that has been created here, including extra volumes and things, if you had extra networks and things, would be automatically decommissioned. So let's go and do a destroy. Again, Terraform will go look at the configuration, read the configuration file, do and build a plan to decide what has to be done to put your action into place, and in this particular case, to destroy the described infrastructure. And it will take a minute or so to give us a plan, which we auto-approved, so it's going to go straight to the decommissioning of things. So it's getting all the details. So if you were working in a DevOps environment where you needed a VM for deploying an application, for example, that would be your final configuration file, which you would want to keep together with the configuration of the application, the source code of the application, maybe in GitHub or in GitLab or whatever is your source code system. And whenever you deploy using Terraform, you always get the same result. So that's the idea of the infrastructure as code. So let's go check here. We should have, I didn't see a plan yet, so we should have a plan. There we go. And the plan is destroy the resource student 1738, sorry, and all the bits that goes with it. Oh, by the way, we see that there was an IP assigned and memory and a lot of things that we didn't look at earlier. And it went on and applied the plan, one to destroy, and it's currently doing the change. So if we go back here, we should and go back to see our instances. We should pretty quickly see that student 1738 will disappear. Oh, there we go. The VM is gone. It was deleted by the Terraform and the Terraform provider through the Terraform provider. Let's go back, finish that cell, and move on to the conclusion of the workshop. Okay, the deploy is complete. One resource was destroyed. So we're good. Let's move to the conclusion of this workshop. So hopefully this was useful for discovering a little bit of what GreenLake is all about, and also private cloud enterprise, as well as Terraform. We only explored Terraform provider with VM, but the Terraform provider has also sections and instructions to do Kubernetes clusters and container as a service, as well as bare metal as a service, so deploying physical servers. So this will be probably another workshop that we build in the future. But if you want to learn more about Terraform, there's lots of documentation. I put the links here, take a look. We have also trial programs for GreenLake, so you can take a look, and we have some ways you can register and take a look. And we have, again, the link to the Terraform provider, which I already shown earlier. Would be really happy if you could take our survey. This is a quick survey in Microsoft Form to tell us what your experience was, and if you liked it or not, what kind of subject you'd like to see cover in the future. And this is very helpful for us to move this forward and improve it, of course. So thank you very much. And this concludes the workshop on demand. You can download, as I said, the notebook and run it locally. You can also, and we ask you to kindly log out if you can. That's easier for the cleanup of the environment. And with that, I would like to thank you very much. Bye-bye.